Hello everyone, this is Sangame, and today I am going to discuss about the factor of safety and general design considerations. Okay, so do subscribe for the latest videos of machine design. So first of all, factor of safety. While designing a component, it is necessary to provide sufficient reserve strength in case of an accident. This is achieved by taking a suitable factor of safety. The factor of safety is defined as it is the ratio of failure stress to the allowable stress or working stress. Working stress, when designing machine parts, it is desirable to keep the stress lower than the maximum or ultimate stress at which the failure of the material takes place. This stress is known as working stress or design stress. It is also known as safe or allowable stress. The allowable stress is the stress value which is used in design to determine the dimensions of the component. It is considered as a stress which the designer expects will not be exceeded under normal operating conditions. For ductile materials, the allowable stress is obtained by the relation sigma is equals to SYT divided by factor of safety, where sigma is the allowable stress and SYT is the yield strength in tension. For the brittle materials, the relation is sigma is equals to SUT divided by factor of safety, where again sigma is the working stress, or it is also called as the allowable stress, and SUT is the ultimate tensile strength. So where SYT, SUT are the yield strength and ultimate strength of the materials, which are respectively used for the ductile material and brittle material. So let us discuss about the reasons or the magnitude of factor of safety depends on which factor. Okay, so the first factor is it is the effect of failure. So sometimes the failure of a machine element involves only a little inconvenience or a loss of time. Example, let us take the example of a failure of a ball bearing in a gearbox. On the other hand, in some cases there is a substantial financial loss or a danger to human life. Let us take the example of a failure of a wall in a pressure vessel. The factor of safety is high in the applications where failure of machine parts may result in serious accidents. Let us take the example of a car and an aeroplane. If you take the example of a gear of a transmission box of a car and a landing gear of the aeroplane, a higher factor of safety would be required for the landing gear of aeroplane, because many lives are depend on that landing gear, because a safe landing is required in case of a aeroplane. If there will be a failure in a gearbox, a failure of a gear will occur in the gearbox of the automobile, that would result in the just breakdown of the vehicle. It will not result in any kind of severe accident. Okay. So the next is the type of load. Okay, the factor of safety is low when the external force acting on machine element is static, that is the load which do not changes with respect to time. Okay, and on the other hand, a higher factor of safety is selected when the machine element is subjected to impact type of load or dynamic type of load. This is due to the fact that the impact load is suddenly applied to the machine component, usually at high velocities. So again, according to the type of load, the factor of safety should be changed. For the loads like dynamic and impact type of load, many of the times we have to go for the higher factor of safety. For the static kind of load, we can go for the lower factor of safety. Third is the degree of accuracy in force analysis. So when the forces acting on machine component are precisely determined, a low factor of safety can be selected. But if the forces acting on the element are not accurately determined, okay, in that case we might have go for the higher factor of safety. When sometimes the magnitude of forces or direction of forces is uncertain, unpredictable, in that case we have to go take the higher factor of safety. Fourth is the material of component. When the component is made up of a homogeneous ductile material like steel, yield strength is the criteria of failure. The factor of safety is usually small in such cases. On the other hand, a cast iron component has non-homogeneous structure. All we know that the cast iron, because of the solidification rate, there might be a structure, variable structure in the same component. Okay, so because of the components which are thin, they get solidified very fast. The crystal structure, whatever the grain size will be different. Okay, in the same components you will get the different types of structures. Okay, so in that case, it is in the case of cast iron, it is unpredictable. To predict the strength of the cast iron is a difficult one. Okay, so in such cases we have to select higher factor of safety, okay, based on the ultimate tensile strength. Next is the reliability of component. In certain applications like continuous process equipment, power stations, or defense equipment, a high reliability of component is expected. Okay, so in these kind of cases, the factor of safety increases with increasing reliability. Obviously, the reliability of the defense equipments or the any fighter plane, and that should be high. For the higher reliability, higher factor of safety should be selected. Next is the cost of component. As the factor of safety increases, dimensions of the component, material requirement, special material requirement may be there. So in that case, cost get increased. Okay, so the factor of safety is low for the cheap machine parts. If you will go for the higher strength alloys, special materials, in that case cost is going to increase. Seventh criteria is testing of machine element. A lower factor of safety can be chosen when the machine component can be tested under actual conditions of service and operation. And in case of the components where actual service condition testing is not possible, in that case you might have to go for the higher factor of safety value. So we can take the example of any space shuttle. Okay, while designing a space shuttle, actually the launching is not possible. Okay, so in that case we might have to go for, obviously we need to go for the higher factor of safety. Okay, next is the service conditions. When the machine element is likely to operate in corrosive atmosphere or high temperature environment or higher, in that case higher factor of safety is necessary. Let us take the example of a connecting rod, or you can take the example of any fastening device which is used in the pressure vessels. So in that case, in the case of pressure vessels or in the case of boilers, whatever the fastening nut bolts are used, those nut bolts are subjected to high temperature. Okay, so there might be a coefficient of thermal expansion. Because of that, there might be a thermal stresses and the component can fail. So for these kind of components, a higher factor of safety is required. So again, it depends on the service condition. Next is the quality of manufacture. When the quality of manufacture is high, variations in dimensions of the machine components are less, and a lower factor of safety can be selected in that case. On the other hand, higher factor of safety is required for the components whose manufacturing is of a poor quality. Okay, now let us discuss about the general considerations in machine design. So first is the type of load and stresses caused by the load. The load on a machine component may act in several ways, due to which the internal stresses are set up. Okay, so already during the previous lecture, we have discussed about the different types of load, about the static load, about the dynamic load, about the suddenly applied and impact type of load, and the suddenly applied and impact type of load are unpredictable type. Okay, so in that case the failure possibility will be higher. Okay, so while designing a machine component or any machine, we need to consider what kind of stress are actually acting on the machine component. I have shown some images of the car. Okay, so here in the first image you can see that some irregularities present over the road. So it is the example of a suddenly applied type of load. Okay, in the first and second images. Also in the third images, you can see that there is an accident, okay, between the two vehicles. Okay, so these are the unpredictable type of loads which can or for these type of loads the object or the component or the machine can be subjected. So these considerations should be these cases or these types of possibilities should be considered before designing the machine, before designing any machine component. Okay. Next is the motion of the parts or the kinematics of the machine. So this is also one more point which is to be considered while designing the machine. The successful operation of any machine depends largely upon the simplest arrangement of parts which will give the motion required. Okay, so as we know that the machine is the combination of many links, mechanisms, and they will have some relative motion between them, and that relative motion should be smoothly executed. Okay, so we should know what kind of motion is required, whether the motion is rectilinear motion or it is reciprocating one or it is curvilinear. So rotary, oscillating, various types of simple harmonic motion is there, various types of motions are there. In some cases constant velocity is required, in some cases constant or variable acceleration is required. Okay, so we should consider all the cases before going to design a machine. Okay, so this is the second part of or this is the point which is to be considered, which is needed to be considered while going to design a machine part or a machine. Third is a selection of materials. It is essential that a designer should have thorough knowledge of the properties of the materials and their behavior under working conditions. Some of the important characteristics of materials are strength, durability, flexibility, weight, resistance to heat, corrosion, ability to cast, welded or hardened, machinability, electrical conductivity, etc. So a design engineer should have the knowledge of all these parameters while selection of materials. It means that he should have the knowledge of what kind of material should be selected for the machine base, as the machine base might be subjected to various types of compressive loads, various types of dynamic types of load, vibrations are induced. So what kind of material, a material like a cast iron should be selected for the machine base, as it can sustain for the higher compressive load. Actually the cast iron is having higher damping capacity, so that kind of knowledge is required. Again, he should have the knowledge of what kind of manufacturing process should be adapted, where the selected material can be casting of selected material can be possible, forging can be possible, welding can be possible or not, case hardening, various machines, various heat treatment processes are there. So while selecting the material according to the application, according to the type of load which acts on that particular component for which we are going to select the material, we should know what kind of processes or what kind of manufacturing process we can adapt for that particular material. In some in cases of some materials, casting will not be possible. In some case of materials, welding will not be possible. So all these considerations should be taken into account while going to design a machine part or a machine. Fourth criteria is form and size of the machine parts. The form and size are based on judgment. The smallest practicable cross section may be used, but it may be checked that the stresses induced in the designed cross section are reasonably safe. In order to design any machine part for form and size, it is necessary to know the forces which the part must sustain. It is also important to anticipate any sudden applied or impact load which may cause the failure. In many of the machine components or many of the machines are there where form and size of the part matters, because in some machines, like, or you can take the example of automobile, a car. In that case, sometimes because of the aesthetic, ergonomics kind of properties, okay, or kind of characteristics, sometimes because of the looks, we might have to go for the lower cross sectional area. Okay, so any component which will be safe for the lower cross sectional area, obviously it will be safe for the higher cross sectional area. So while selecting a form, shape, size, a designer should consider loads acting on that particular component also, because sometimes because of the looks or external appearance, whatever the shape, size, thickness of the component, that is get reduced. So actually whatever the function of the component is there, according to the design consideration, it should be it should perform very well. Okay, so it should not fail in working condition because of the loads acting on the component. So design engineer should consider what kind of load is acting on the component. Okay, if the component will be safe for the smallest cross section, obviously it will be safe for the largest cross section of the same component. Okay, so while designing a machine, while selecting a form, shape, size, part of the any machine, a design engineer should consider whether the smallest cross section is safe or not. Okay, next is the frictional resistance and lubrication. Okay, so there is always a loss of power due to frictional resistance, and it should be noted that the friction of the starting is higher than that of a running friction, as I have already said in the previous lecture during the design of machine parts. Okay, the friction should be considered while designing the machine parts. Okay, the friction will be maximum when the component will move from the state of rest to the state of motion. Okay, so during that part there is a possibility of failure of the component will be there. Okay, so while designing any machine, any component, we should consider the friction, static friction, dynamic friction. Okay, all these possibilities. Okay, and according to that we should provide the proper lubrication also. Okay, to reduce the friction. That is the one way to reduce the wear and tear and the replacement, or to reduce the maintenance of the product. So many components are there, like rotating shafts are there, sliding mechanisms are there, like piston and cylinder is one kind of a sliding pair. Okay, roller bearings, ball bearings are there, also many sprockets, wheels are there, chains, drives are there. So there is a lot of friction between the relative motion between these all parts. Okay, to reduce the friction we should provide the proper lubrication. Okay, so that the frictional resistances can be reduced, and whatever the stresses induced in the component because of the frictional resistance, that can be ultimately reduced. Next is the use of standard parts. Okay, this is the one kind of a general consideration in machine design. While designing a machine, we should know what kind of standard parts are available with us in our shop. The use of standard parts is closely related to cost, because the cost of standard or stock part is only a fraction of the cost of similar part made to order. The standard or stock parts should be used whenever possible. Parts for which patterns are already in existence, such as gears, pulleys, bearings, parts which may be selected from the regular shop stock, such as screws, nuts, pins, bolts, studs, should be as few as possible to avoid the delay caused by the changing drills, reamers and taps, and also to decrease the number of wrenches required. Okay, so these much of considerations, these much of points should be considered while designing a machine. So we should go for the as much as standard part. Okay, instead of designing or manufacturing in-house the components, many of the nut, bolts, levers, wheels, bearings are readily available. Okay, so we can purchase that, or we can use the components which are stored in the workshop. Okay, next is the convenient and economical features. While designing the machine, the operating features of the machine should be carefully studied. The starting, the controlling, the stopping lever should be located on the basis of convenient handling. The adjustment for wear must be provided, employing the various take-up devices and arranging them so that the alignment of parts is preserved. If the parts are to be changed for different products or replaced on account of wear or breakage, easy access should be provided, and the necessity of removing other parts to accomplish this should be avoided if possible. The economical operation of the machine, which is not to be used for production or for the processing of material, should be studied in order to learn whether it has the maximum capacity consistent with the production of good work. So here I have shown some images. You can see that whatever the maintenance is there, whatever the breakage, whatever the replacement of parts is there, okay, because of the wear and tear, that should be easily done. Okay, so while designing the machine, we should consider all these points. Okay, if any part is which is needed to be frequently changed, in that case that part should be easily accessible. Let us take the example of engine oil which we need to replace for every near about 10,000 kilometers for the a four-wheeler or any four-wheeler automobile. Okay, so while replacing the engine oil, that whatever the lead or the cap which is needed to be removed while replacing the engine oil, that should be easily accessible. Okay, so many parts are there. In that case, sometimes it is quite difficult to access the parts for the replacement, for the maintenance. So while designing the machine, a design engineer should consider such kind of cases. So whether the part is frequently changed or whether it will be changed after very long time. So in that case, that location of that part is important. If the part is frequently changed, if you will take the example of tires which are generally changed after 35 to 40,000 kilometers for the four-wheeler. Okay, it is quite easy to replace the car tire by changing by removing it from the axle. Okay, let us take the example of clutch lining. Again, it is quite difficult because it is the part of engine. So in that case, there should be at least minimum part should be removed while doing the maintenance of any part which is frequently changed. So that is the point which is needed to be considered by the design engineer. If suppose that part will not be easily accessible for the maintenance purpose, in that case he might feel the difficulty. Sometimes what will happen, to do the maintenance of the proper part, we might have to remove some other parts. So in that case, breakage or damage of the other parts might happen. Okay, so a convenient and economical feature is the part of this part should be. This is also important part of general considerations of machine design. Next is the safety of operation. Some machines are dangerous to operate, especially those which are speeded up to ensure production at maximum rate. Therefore, any moving part of machine which is within the zone of worker is considered an accident hazard and may be the cause of injury. It is therefore necessary that a designer should always provide a safety devices for the safety of the operator. The safety appliances should in no way interfere with the operation of the machine. Okay, so I have shown some images here. You can see that worker can commit to accident because of the moving parts of the machine. So a safety barricades or safety protection devices or any kind of protecting cover should be provided for the moving parts, so that because of the motion of that particular part, a worker cannot get injured. So I have given some images where the possibility of injury is there, and there is a solution for these kind of parts. You can provide the barricades, you can provide the safety covers. Okay, so while designing a machine, a design engineer should consider what kind of moving parts, what kind of projected parts are there which are working out of machine. Because of that, those kind of moving parts, like sometimes chain drives are there, sometimes cam followers or crank and piston type of mechanisms, or sometimes these kind of mechanisms are located outside of machines. So there is a possibility of sometimes rollers are there, okay, sprockets are there, gears are there. So these motion parts can be the reason of accident. So to avoid the accident, a design engineer should provide the protective cover or any kind of protective you can consider it as a protective layer over these kind of components. Okay, so safety operation is also an important part, important general machine design consideration. Next is the workshop facilities. While going for the design of any machine, while manufacturing any part, while doing the assembly or before doing the assembly, before going for the design of whole machine, okay, a design engineer should be aware whatever the facilities, workshop facilities available with him. A design engineer should be familiar with the limitations of his workshop. He should, in order to avoid the necessity of having work done in some other workshop. It is sometimes necessary to plan and supervise the workshop operations and to draft methods for casting, handling and machining special parts. Okay, so a design engineer should be familiar with the limitations or the facilities available with him within his company's workshop. Okay, Next is the number of machines to be manufactured. This is also one important part which is to be considered while designing or doing the general considerations for the machine design. A number of machines to be manufactured, the number of articles or machines to be manufactured affect the design in number of ways. The engineering and shop costs, which are called fixed charges or overhead expenses, are distributed over the number of articles to be manufactured. Obviously, if you will take the example of the tractor, which is mostly used in the agricultural equipment for the harvesting of agricultural land. Okay, so many of the in India, a lot of farming sector is there. So the whatever the sale of tractor or what are the number of tractors yearly sold out in India are larger. But if you go for the some special equipment like sugar cane harvesting machine, here you can see that, or the crop harvesting machine, these machines are costlier and larger one. Okay, so these cost near about one in terms of crores, and these machines like tractors cost near about in terms of lakhs. Okay, so the number of machines sold out overall, number of tractors sold out in India is obviously it will be more. Okay, and the machines like these special machines like sugarcane harvesting machine is there, or crop harvesting machines, multi-purpose crop harvesting machine is there. Okay, so whatever the production rate or the sale for this kind of heavy large machine, that will be less comparatively tractors. Okay, so only a few articles like these products or few machines will be produced during the year. Okay, so extra expenses are not justified unless the machine is large or some special design is required. So an order of calling for small number of products will not permit any undue. Okay, so again, while designing a machine, what kind of machine is there, how many machines a design engineer or a firm is going to sell for every year. Okay, that is also going to matter. Okay, so this is also an important consideration while doing a machine design. Next is the cost of construction. The cost of construction of an article is the most important consideration involved in design. In some cases, it is quite possible that the high cost of an article may immediately bar it from the further considerations. If an article or a machine has been invented and tests of handmade samples have shown that it has commercial value, it is then possible to justify the expenditure of considerable sum of money in the design and development of automatic machines to produce the article, especially if it can be sold in large numbers. The aim of design engineer under all these conditions should be to reduce the manufacturing cost to minimum. Okay, so again, I would like to give the example of the tractors, which are frequently used in agricultural sector, and if you will go for the multi-purpose crop harvesting machine. Okay, so the cost, obviously the cost of multi-purpose crop harvesting machine, that will be high comparatively the tractor. Again, the cost of construction is matters. It is the main important part. You can call it as the main important consideration while doing the machine design. Okay, so the cost is also that should be considered while going for the design of machine. Next is the assembling. Okay, so every machine or structure must be assembled as a unit before it can function. Large unit must often be assembled in the shop, tested, and then taken to be transported to their places of service. The final location of any machine is important, and the design engineer must anticipate the exact location and the local facilities for erection. Sometimes sometimes machine is assembled inside the large workshop, and the testing is not possible in that. Testing facility will not be available, because whatever the working conditions that are required for that particular machine, that may not be available inside the plant. Okay, so if you will go for the I have shown two examples here. One, you can take the example of earth moving equipment. Okay, so it is quite large one. Okay, while assembly is possible, again testing in few in few manners testing is also possible. But again, according to the working condition, we might not know for what condition the earth moving equipment, whatever the bulldozer or whatever the that earth moving equipment that will be used, whether it is used for the soft soil or whether it is used for the rocks, for the digging of the rocks, etc. Okay, so that every working condition, that environment creation is not possible inside the workshop. Okay, so again, let us take the example of an aeroplane. Okay, assembly of aeroplane is possible. Again, testing is also possible, but whatever the environmental working conditions are there, weather conditions are there, for that particular weather conditions, the testing might not be possible inside the workshop, because that artificial environment cannot be created, so that if you'll take the example of aeroplane, how it is going to function during the rainy season, what kind of, again, many situations are there, like whatever the road for the landing facilities available or takeoff facilities available, that every situation cannot be you can call it as it cannot be created inside the workshop. So again, assembly is possible for the large machine, but the testing facility is the important part. Okay, so these points should be considered. As a design engineer, he should consider all the points which I have mentioned as general considerations in machine design. Okay, thank you.